Think about the last time you actually dialed a 10-digit phone number from memory. Most of us don't do that anymore. We just tap a name on a screen and the phone handles the numerical routing behind the scenes. The entire internet operates with that exact same communication barrier. This diagram shows two very different languages. On the left, we have the easy-to-read website names we use every day. But on the right, you see the complex strings of numbers that computers actually use to find each other across the network. To bridge that gap, the internet relies on the domain name system, or DNS. It's an invisible global directory that instantly translates the human words you type into the specific numbers the machines need. We are going to freeze time the exact moment you hit enter on your keyboard, tracking precisely how the system finds your destination. Without this translation system, using the web would require memorizing thousands of complex numeric addresses just to check your email or watch a simple video. The journey starts immediately after you type a web address, right inside your own computer. Before a single piece of data leaves your house, your computer checks its own short-term memory. It looks to see if you visited this site recently and if it still remembers the correct number. But if you're visiting a site for the first time, your computer's memory comes up blank. The request now leaves your house and travels out to a specialized search agent, a server known as a recursive resolver. Think of this server as a digital investigator. As you can see in the diagram, it doesn't actually have a master list of every website on Earth. Instead, its job is to go out and hunt down the answer on your behalf. This investigator takes the heavy lifting off your computer, starting a high-speed search across the global network to find the one record you need. To find that specific record, the search agent has to navigate a massive, worldwide hierarchy of interconnected data centers. Its first stop is at the very top of the system, the root servers. These are the ultimate authorities of the entire internet directory. The root server only looks at the extension, like .com, and maps a path to the top-level domain server. This extension server evaluates the specific brand name, pointing you to the final destination, the authoritative server managing that company's exact records. Here it is. This is the authoritative name server. This is the only place in the chain that holds the official source of truth file for the website you're looking for. The authoritative server pulls the exact numeric address directly from its database and hands it directly back to your investigator, who then races it all the way back to your computer. The most incredible part? This entire global search across multiple layers of servers happens in just a few thousandths of a second. While this system is fast, the original design was created decades ago, before security was a top priority. In this diagram, notice how the data packet is transparent. Standard DNS requests are sent in plain text, meaning anyone sitting on the network between you and the server can see exactly which website you're trying to visit. This makes it easy for curious observers, like your service provider or a corporate network, to keep a log of everywhere you go online. Worse, a hacker can intercept that transparent request and send back a fake address before the real one arrives. This is called spoofing, and it can trick your computer into loading a fraudulent website without you ever knowing. Because the system was built on trust, your computer has no easy way to tell if the address it received is the real one or a dangerous fake. To fix this, we've developed new ways to seal the conversation and verify the results. We can now wrap your request inside a secure privacy tunnel. This is called DNS over HTTPS. As you can see, it hides your request inside encrypted web traffic, so no one on the outside can see where you're going. To make sure the answer hasn't been tampered with, we also use something called DNSEC. Think of this as a digital notary. It adds a unique cryptographic signature to the record itself. By checking this digital signature, your computer can prove that the address it received is authentic and hasn't been changed by a hacker. So the next time you type a web address and hit enter, remember that your journey is powered by a high-speed, highly secure, and invisible global relay race that makes the modern internet possible.